I want to prove that the limit as x approaches 1 of 1 over x is equal to 1. So here I'm going to start with the absolute value of f of x minus my limit less than epsilon. My function here is 1 over x. My limit is 1. So that means that 1 over x minus 1 is between negative epsilon and epsilon. I'm going to add 1. So we have 1 minus epsilon less than 1 over x less than 1 plus epsilon. And now I'm going to flip everything. And when I flip, the inequality changes. So it'll be 1 over 1 minus epsilon greater than x greater than 1 over 1 plus epsilon. And now we have our first inequality for x. The second one is going to come from x minus c less than delta. C is the x value that I'm approaching, which is 1. So we'll have absolute value of x minus 1 less than delta. So that means x minus 1 is between negative delta and delta. I'm going to add 1. So we have 1 minus delta is less than x less than 1 plus delta. And now we have our second inequality of x. The next step is to set the lower bounds equal to each other. So we're going to have 1 minus delta equal to 1 over 1 plus epsilon. So we'll have 1 minus delta equals 1 over 1 plus epsilon. I'm going to move the 1 over 1 plus epsilon over, and I'm going to move the delta over. So I'm going to have 1 minus 1 over 1 plus epsilon equals delta. And I can simplify this further and say that delta is equal to epsilon over 1 plus epsilon. Okay, and so that's our first delta. The next delta, we want to set the upper bounds equal to each other. So the upper bounds for x. So in other words, 1 plus delta and 1 over 1 minus epsilon. I'm going to subtract by 1. So I have 1 over 1 minus epsilon minus 1. And here when I subtract these, let's see, I get 1 minus epsilon at the bottom. And here we can write 1 minus epsilon over 1 minus epsilon. So it'll be 1 minus 1, so that's 0. And then the negative epsilon will just make it positive epsilon. That'll be delta equals epsilon over 1 minus epsilon. And now that I have the two deltas, I always want to find the smaller delta. So I'm going to be looking at the minimum. So delta is the minimum of epsilon over 1 plus epsilon and epsilon over 1 minus epsilon. And clearly the minimum will be epsilon over 1 minus epsilon because, 1 plus epsilon. Because the denominators, well, the numerators are the same, so you look at the denominator. 1 plus epsilon is bigger than 1 minus epsilon. So the bigger the denominator, the smaller the number is. So epsilon over 1 plus epsilon is the delta that we need. Okay. Let's try another one. Okay, now we'll have 1 over x squared. So we have the limit as x approaches root 3 of 1 over x squared is equal to 1/3. We're going to start the same way, and we're going to be looking at the absolute value of f of x minus my limit less than epsilon. And my function here is 1 over x squared. My limit is 1/3, and that's less than epsilon. So that means 1 over x squared minus 1/3 is between negative epsilon and epsilon. I'm going to add the 1/3 over. So we have 1/3 minus epsilon less than 1 over x squared less than 1/3 plus epsilon. And the next step, I'm going to flip everything. So, well, let's do this first. Let's get each one of these into a fraction. So one single fraction. So 1 over 3 minus epsilon will just be 1 minus 3 epsilon over 3. And that's less than 1 over x squared less than 1 plus 3 epsilon over 3. Now I'm going to flip. So I'm going to have 3 on top over 1 minus 3 epsilon. The inequality changes. And then we have x squared. And that will be 3 over 1 plus 3 epsilon. Now I want to get x instead of x squared, so I'm going to take the square root of everything. So we'll have the square root of 3 over 1 minus 3 epsilon. And here we're having the square root of x squared. So the square root of x squared we know is the absolute value of x. But here x, the x that we're approaching is root 3. So we can just get rid of the absolute values and just leave it as x, since root 3 is positive. So that means we can just say it's x greater than square root 3 over 1 plus 3 epsilon. And that's our first inequality for x. Okay, the next one, we want to look at the absolute value of x minus c less than delta. C is the x value that we're approaching, which we said was square root 3. Okay, and now what we have to do is, let's see, we'll have x minus root 3 between, that's between negative delta and delta. We'll add root 3 to the left and the right. Oops. So we have root 3 minus delta less than x less than root 3 plus delta. And that's our second inequality that involves x. And now what we have to do is set the lower and upper bounds equal to each other. So we'll start with the lower. So the root 3 minus delta, we'll set it equal to the square root 3 over 1 plus 3 epsilon. And so that means root 3 minus 3 over 1 plus 3 epsilon is going to be delta. And then finally we can set the upper bounds equal to each other. So we'll have root 3 plus delta is equal to root 3 over 1 minus 3 epsilon. And so delta is going to be root 3 over 1 minus 3 epsilon minus root 3. Okay, and from here, we just want to find the minimum. So delta will be the minimum of root 3 minus root 3 over 1 plus 3 epsilon and root 3 over 1 minus 3 epsilon minus root 3. Okay. So here it's not obvious which one is smaller. So we'll just leave it like this. So we'll just choose the smaller of the two. And that completes the proof.